Today we're going to be talking about numerical representations, and first let's go ahead and start off with the real number system. And so here we have a diagram of the real number system, and in the very first box that's labeled A, that little one, those are going to be natural numbers. Natural numbers are positive counting numbers starting with 1. Okay, so let's go ahead and put that those are natural or counting numbers. You can also call them counting numbers. Counting or natural numbers. Okay. B is going to be the part in orange, right? So because B is outside of A, that means everything that's inside of A is also whatever B is. And B, it says positive numbers counting starting with 0. So positive numbers counting with and starting with 0 are whole numbers. So that means that all natural numbers are whole numbers. Okay. Then next one, let's look at C. So here we have C, and then A and B are inside of it. So that means that whatever A and B are, they're also what C is. And so let's see. C is whole numbers and they're opposites. So positive and negative numbers, those are going to be integers. So that means whole numbers are integers, natural numbers are integers, but not all integers are whole numbers, right? And same thing, not all integers are natural numbers. You can go the other way, but not forwards, right? For D, let's see D, let's put that in purple. We can see D, it's outside of C and D, so whatever D is, A, B, C are also D, but not everything that's inside of D is going to be A, B, C. So D, it says fractions, repeating decimals, and terminating decimals. So terminating means that they end. Those are going to be rational numbers. Rational numbers. Okay. E is off to the side, so that means that if we have E is not going to be anything that is related to rational numbers and everything that's related to rational numbers. So it can't be integers, it can't be whole, it can't be natural, because they're off to the side and they're not even inside or outside of A, B, C, D. Okay. What they are real numbers. But E is going to be non-terminating or non-repeating, so they don't end and they don't repeat. Decimals, and they're non-perfect squares. Okay, so they're going to be like square root of 2, square root of 3, right? So, something that's not a square. And those are going to be irrational numbers. Okay. Altogether, all of them, something that you know for sure, all of them are real numbers because they are all in this space right here inside real numbers. Later on in high school, you'll learn about imaginary numbers, and it'll actually be its own little box for imaginary. Okay, but for right now, we're just looking at real numbers. Let's go ahead and go to square root. Okay, so a square root, a number means that a number times itself will give you the number inside the square root. Okay. So we're going to estimate the non-perfect squares by using the number line. For example, to find the square root of 80, find the two closest perfect squares. In this case, the two closest perfect squares would be 64 and 81, and we can take the square root of those, and we know the square root of 64 is 8, and the square root of 81 is 9. When you have the number line, you will know that it's the square root of 80 would be less than 9, or 9, or sorry, 8.9, right? A little bit over 8, right? Something you can also do, you can just put in the calculator. We are fortunate to use the calculator, but remember, whatever you put in the calculator is what you're going to get as a result. So please be careful in putting whatever you want to in the calculator. Okay. So something that we can do this with square roots is if we're given the area, the side length of the square can be found by taking the square root, or sorry, just square, square root of the area. Okay. So if we're given the area, let's say the area is 16, the area is 16, we can know the side length over here will be 4, right? Because the square root of 16 is 4, and if we have a square, 4 times 4, it will give us 16. Okay. Let's go ahead and look at scientific notation. For scientific notation, it is a value written as the product of a number between 1 and 0, or 1 and 10, sorry, and the power of 10. Okay. So here we have, there's a product right here between a number between 1 and 10, so that's this part right here, and the power of 10. Okay. So we would have power, and then whatever our exponent is would be our exponent. Okay. Remember to check to see if the exponent is positive or negative. Right? It can be either the first or the second. Okay. So the way we do this, a refresher on how we do this. Let's take this one right here. I'm going to put 4.235. My exponent is a positive 7. So if it's a positive 7, my decimal is going to go to the right 7 times. So I'm going to move it 1, 2, 3, 4, 5, 6, 7. This is where my new decimal is going to be. Okay. What I do with the rest of the jumps, we're going to fill them in with zeros. And this number in scientific notation is this number in standard form. Okay, so 42,350,000. Okay. Let's do the other one. We have 6.88. This time our exponent is negative, so we're going to go to the left 7 times. So if we move to the left 7 times, and let me move this over a little. We're moving our decimal 1, 2, 3, 4, 5, 6, 7. This is where our new decimal is. And everything else we can fill in with zeros. Okay. So here we have a decimal. If you want, you can put 0 point and then 1, 2, 3, 4, 5, 6 zeros. And then we have that 688. Okay. And that's what it would be in standard form. If we go from standard form to scientific, this is how we would do it. We would put our number. Okay. Our decimal is right here at the very end, because there's no decimal in between there for right now. We want to make a number that is between 1 and 10. So if I put my decimal here, it'll give me 12.92. That's not between 1 and 10. So I have to not put it there. I'm going to put it actually right here. Okay. So I'm going to see how many jumps it takes to get to this spot, because that spot, it will give me 1.29, and that's between 1 and 10. Okay, so I'm going to count 1, 2, 3, 4, 5. It gives me 5 jumps, and I did, I am going from big number to small number, right? So let me go ahead and put this as 1.292. We're going to multiply by 10, and then our exponent, since we're going from standard to scientific, it's going to be the opposite of what we did here, because we're going the opposite way, right? So because from going from standard to scientific, since we're going that way, we're going to make it into a positive 5 because we did 5 jumps. Okay. For the next one, let's do 0.000097. Again, we want to make a number that will give us between 1 and 10. Okay, so if I put it here, it'll give me 0.97. 0.97 is less than 1. It's not between 1 and 10. So I do not want 0.97. Let me move it over here. We get 9.7. That's between 1 and 10. So that's what I'm going to do. So I'm going to see how many times I went. I'm going to the right. So we got 1, 2, 3, 4, 5 times. Okay. So this time we're going to write our 9.7 times 10, since we're going to the right, and it's from standard to scientific, we're going to have it as a -5. Let's do the last one, which is ordering numbers. Ordering numbers is just putting numbers in the same form first. For example, you can convert numbers to decimals before ordering them. I suggest doing it in decimals, so that way you can see which one is greater or less. And then the key words to what a question would say, like let's say you wanted to do it from least to greatest, you would actually you'll find the words increasing and ascending. Okay. If the word problem wanted you to order them from greatest to least, you would see words like decreasing and descending.